Creating assessments and rubrics for maker projects. Assessment is an important part of teaching and learning. It allows us to gauge, track, and respond to student learning. We want students to grow, and it is important to measure that growth. An important concept when using projects is the idea of authentic assessment. Authentic assessment is not a particular type of measurement, but the practice of using the right tools to measure the right objectives. A multiple choice quiz might work well to see what students remember, but it won't measure how well students can make. Performance or product assessments, which assess how students perform or the quality of what students produce, are used for projects and especially maker projects. Performance or product assessments use rubrics to measure quality in the most objective way possible. A key idea to remember when creating and using rubrics is that they are not a checklist. They are a way to show levels of quality. A rubric shouldn't score a student higher if they are just doing more of the same work. It should require them to do deeper thinking or work with trickier applications. We're going to create rubrics using 3 simple steps. 1. List the central criteria for completing the project, including both maker and academic criteria. 2. Narrow down the criteria. And 3. Write descriptions for each level of each criteria. Step 1. Listing the central criteria for completing the project. Take a moment to look back at your learning objectives and your driving question. List all of the criteria that would be a successful completion of this project. Don't worry about the list being too long quite yet. In step 2, we will narrow the list down. Make sure to include the maker learning objectives as well as the academic learning standards for this project. For our example, we were having students create a plan for a computer program that would help businesses save money. We're using the maker concept of programming and demonstrating the path of a program using a chart. Let's also say that I'm integrating the Common Core Math Standard 7EEB4. Use variables to represent quantities in a real-world or mathematical problem and construct simple equations and inequalities to solve problems by reasoning about the quantities. So I'm going to have them design the flow of a program that would use some simple equations to help businesses. For the first step, I should list everything I want the students to be able to do with the project. By doing a little bit of research on charting program paths, I see that the following criteria seem relevant. Using appropriate shapes and symbols to represent key parts of the program, understand the larger program design context, understand aspects of programs like decisions, procedures, and loops. And for the math standards, I will have criteria of identifying a real-world problem to build an equation or inequality, identifying the variables, identify the sequence of operations used to solve, compare an algebraic solution to an arithmetic solution, plot solutions on a graph. So far, that is a lot of criteria for one project with only one academic standard. So let's move to step 2 and narrow down our criteria. We should really only assess students on what we are explicitly teaching them. So we should look back at our criteria and decide what we absolutely need in this project and what we might not teach or might save for a later project. For the maker portion of this project, I'm going to eliminate that students need to know the different aspects of programs. That would be nice to teach, but is also a bit more advanced than I need for this project. It will come in better in another project. For the math part, I'm really focusing on students being able to create their own equations or inequalities, so I'm not going to focus on graphing the final solutions, and I'm not going to assess them on their ability to compare the algebraic solution to an arithmetic solution in this current project. Step 3. Write the descriptions for each level of each criteria. On a 4-scale rubric, the best place to start writing your descriptions is at level 3, the level that meets expectations. In level 3, you will describe what a student does to meet expectations. For example, for the criteria of using appropriate shapes and symbols to represent key parts of the diagram, I can write in, used appropriate symbols to represent key parts of the diagram. That was really simple. Writing level 3 is sometimes really easy. Now I can move to level 2 or 4. I'm going to move to 2 because that seems like the next most obvious. Level 2 is if a student is almost there but not quite. Let's say they had just made some simple mistakes but generally seem to understand it. I'll put in mostly used appropriate symbols to represent key parts of the diagram. Some minor errors in symbol use. And now I'm thinking that level 1 would be if they misused symbols on key parts of the diagram or mostly misused symbols. Now how about level 4? What would it mean to go above and beyond? What would be really great use of symbols in this diagram? Perhaps it would be something I would need to research some more. Maybe it would be that the student made it extra clear, or maybe they went into an extra level of detail and provided extra descriptions where appropriate. Maybe it is a combination. How about used symbols and added descriptions appropriately to represent key parts of the diagram creating a very clear and descriptive plan. To finish creating the rubric, I would continue following this formula. At some points, you may need to research what makes something a level 4 versus a 3. Just try to draft out your rubric and then review and revise it once you have gotten all of your ideas down. In review, the steps to creating our assessment rubric are: list all the criteria for the project, maker and academic, narrow down the criteria, and write your descriptions. You can now use your rubric as an assessment tool for your final project, but you can also construct a simple pre-assessment based on your rubric. In our next and final video, we will plan how to scaffold our maker concepts.